Alright everybody, welcome back to another video. This is the last part of the series where we're actually going to be adding a new feature to the game. And that new feature is going to be the ability to drop spores and lose mass over time. And this is just really going to incentivize players to keep playing the game, keep eating spores, and keep hunting down other players. Because otherwise they will shrink in size and they could possibly be in peril. So in the last video, we added a high score board and a leaderboard to our game. And in this part, we just want to, like I said, give players a random chance to drop a spore. And yeah, we're also going to be allowing players to search the leaderboard to find themselves by name or search for their friends by name. So this should be a bit of a shorter video, hopefully. But first, let's get into the homework solution at the end of the last video. So as it stands, it's currently not possible to go back to the connected screen from the Hiscores screen. So let's go ahead and add a button to request the connected scene again, and we'll transition back to that state. Before I forget, if you do want to follow along at home, you can always come to tbat.me/projects, click on the Godot 4 and Golang MMO tutorial series, and scroll down till you find part 10. So we're getting close to the end. And you can find the source code for the last video. So this is the source code for the end of the previous video. If you want to download this and import it, you'll be set up to follow along with this part. But if you've been following along so far, let's get started with the homework solution. So there's multiple ways to approach this, but here's how I would do it. I'm going to make a new packet called finished browsing high scores. And it's going to be another empty payload packet. So this is going to be sent from the client to the server when they are finished browsing. Let me recompile my protocol buffers. I'm going to get the server to start listening to this packet in the browsing high scores state. So and we're simply going to transition back to the connected state. So b.client.setState connected. So we just need a way to send this packet from the client. So let's add a new button to our scene. The way that it's set up at the moment, it's going to be a little bit difficult to position the button nicely. So I'm just going to reorganize a little bit. I'll add a VBox container. I'm going to use the full rect preset. I'm going to make the high scores node a child of the VBox container. And let me just add a back button here, just at the top. So it's still not going to look the prettiest, but we will be making everything look nice in the next part. So maybe let me just make the VBox container like just like this or something like that. It's really not too important. So now I'm going to attach a script to the scene or modify the existing script. And I just need to put a VBox container in between the UI and the high scores node since we rearranged things. And I'm going to add a reference to our back button. So I'm actually going to rename this to back button. And I'm going to connect the back button up to a handler. And then we're simply going to construct a finished browsing high scores packet and send it to the server. And after we send the packet, we're going to tell the game manager to set the state to the connected state. All right, let's see if that works. I'll need to rerun the server. And let's look at the high scores and we can click the back button. And we should now be in the connected state. Yep, so switching from browsing to connected. And if I log in, we should still be able to interpret that. All right, looking good. So that's the homework solution out of the way. Let's get into the main feature of today's lesson, which is the ability to drop spores. So there's, again, many ways we could implement this one, but probably the simplest and most low effort approach is to hook into the sync player method on the in-game state. So we already have something that runs in a loop every few seconds. So what we can do is inside this method, we can just add a probability check, which if the check passes, we can drop a spore, which basically means creating a new spore on the server and then sending a new spore packet to the client. Or I suppose broadcasting that new spore packet, because we have already configured this state to forward new spore packets directly to the client. So let's just do this right after we update the player's position, but before we broadcast the update, because when we drop a spore, we're going to decrease our mass as well. So if we decrease the player's mass here, that will be captured by the update packet. So this is probably the most effective way to put this. So let's say drop a spore, and then that logic will go here. And then this is just going to say, I'm just going to put a comment here to say this is separate, broadcast the updated player state. Cool. So let's say that the probability of dropping a spore is going to be proportional to the player's radius. So as the player grows, there's going to be a higher and higher chance that they're going to drop a spore each sync. So let's say g.player.radius, and let's divide this by, let's make it also inversely proportional to the number of maximum spores on the server. So we'll divide it by the server's max spores times 5. So you can probably tell I played around with these values a little bit and I found this to work well, but you're of course free to choose any number as long as it's between 0 and 1. So I suppose I would be in a bit of trouble here if the player's radius was more than 5,000, because that would make this more than 1. Well, I suppose it wouldn't be that bad. It would just mean that we're dropping a spore every sync, which if you're that big is probably a good thing. So if rand.float64 is less than probability, and we also don't want to drop any spores if the player's radius is smaller than the starting radius or smaller than 10. So let's just also require that the g.player.radius is greater than 10. We'll create a new spore object at our x and y coordinate, and we'll give it a radius of, we'll make the radius proportional to our radius just for fun. So I played around, I think the minimum of 5 plus g.player.radius over 50 and 15 is a pretty good size. All right, so that's our spore that we're going to drop. Let's add it to the shared collection and get the ID. And then we're going to broadcast this new spore. So the broadcast method actually only sends it to other clients. It doesn't send it to our own, WebSocket connection. So we're also going to send it to ourselves. And we're going to do that in the background just because socket stuff could always introduce some blocking or some delays. So socket send packets.new spore. So this is a new spore packet with the spore ID and the spore object that we just created. And then we'll go ahead and decrease our radius. So g.player.radius equals g.nextRadius. And here, if we give it a negative mass, this will decrease our radius. All right, so just fix up my typo. So this is everything we need to drop spores and start sending those spores on a random probability every time the player is synced. So let me rerun the server and let's see if it works. So I'm just going to eat a few spores to increase my mass and therefore increase my probability of dropping a spore. We should see it happen soon. Oh yeah, you probably saw it there. It's a little bit hard to tell, but basically what's happening is we're dropping a spore, it appears directly on top of us, and then we immediately eat it again. Because there's no checks to see if the spore that came in was dropped by us. We shouldn't eat it straight away. Shouldn't be allowed. Yeah. Alright, so we've got a couple things to do in order to fix this. We need to make the client not consume spores if they spawn on top of them. And we also need to make a new validation check, because if someone hacked their client to ignore that first check, so if someone hacked the client to make it so that they can consume spores that spawn on top of them, basically they would never decrease in size. So we need to add a validation check on the server to basically just make sure that this can't happen. All right, so let's tackle the first problem first. Let's ignore spores that spawn on top of actors. So let's come into spore.gd, which is in our objects/spores folder, spore.gd. And we're going to add a new flag. So as well as these flags here, we're going to have one called underneath player, which will be a Boolean. And we're going to use this in our instantiate script as well. So just after radius, we'll have underneath player, and we will set that attribute as well. All right, so basically in the in-game script now, we can pass that in. So let's see. It's actually highlighting the part that we need to fix because there's an error. We're only passing in 4 arguments instead of 5. So let's see if we can determine whether or not, I'll just comment this part out for now. Let's see if we can determine whether or not the spore spawned underneath the player. So we're going to set underneath player initially to false. And then we only need to worry about the case where the spore spawns on top of our player. Because if it spawns on top of another actor, well, there's no logic for other actors to be consuming spores. We only run that kind of logic on our own player. The server tells us about the other networked actors consuming spores. So really, we just need to check if ourselves as a player exists yet, because I think there's a case where spores are initially spawning from the server, but we are not in the game. That might not be quite right, but it doesn't hurt to check. So I'm just going to check if GameManager.client ID is in our players dictionary. Then we can go ahead and grab our player. We can grab our position. We'll get it as a vector2 so that we can do some vector maths on it. We can grab the spores position as well from the payload. And then we'll just say underneath player equals player position dot distance squared 2 spore position is less than our radius squared. So this is how we can determine whether or not the spore's position is within our own radius. And then what we can do is uncomment this out, and we just want to pass in underneath player to the instantiate method there. So what's going to happen if this is set? Basically, we just don't want to consume the spore. So let's find the consume spore function. And instead of doing all this, let's only do this if the spore is not underneath the player. So I guess we can just do like an early return. So if spore.underneath player, return. So we're just going to refuse to consume a spore that's underneath us. But then what's going to happen, maybe to demonstrate this, I will just make the probability that we spawn a spore. I'm just always going to make this 1. So we're going to spawn a spore every sync, just so I can demonstrate the point. So we're going to refuse to consume these if they are underneath us. So that's looking good. But then, and notice how we can, eat these spores that were here before. But what if we want to eat one of the spores that we dropped? Well, obviously we can't do it because we said if it spawned underneath us, we're going to refuse to consume it. But it's not underneath us anymore. So we should be able to consume these after we have stopped colliding with them. So let's fix that. We'll come to the spore script, and we're going to connect the area2d's area exited signal if this is our player. So in the ready function, let's just say if underneath player area exited. So this is a signal that comes with the area2d node, which we inherit from, dot connect, and we'll give it a custom handler. And let's make this handler down here. Oh, and I believe it takes an area2d node. Okay, yeah. So area2d. We'll just check if area is actor. So yeah, this is, so far it's saying if the spore was underneath the player, we're going to connect the area exited signal to say that if the area that was exited was the actor, then we can just set underneath player to false. All right, so it looks like I need to import actor, const actor, preload actor / actor.gd. So we're just going to unset this flag anytime the collision exits. And let's see if we can drop our spores now. Oh, we can drop our spores, but let's see if we can pick them back up again. Yep, looks good to me. It kind of just looks like we're dropping them straight away, because we are. But yeah, you can see that we are at least getting bigger just by the fact that we are able to drop spores again. It means that our radius is no longer 10. Cool. So let me just make it so that the probability is proportional to our radius again, and I'll rerun the server. So I suppose in a perfect world, we would be finished with this feature. But unfortunately, we do not live in a perfect world, and clients may be hacked, and we have to assume that could be the case, at least for our project. So if someone simply removed, if someone got hold of their Godot client, somehow decompiled the code, and removed this line of code here, they would be back in the same position as we were before, where they are telling the server that they are eating spores that were spawned on top of them. So in order to safeguard against that, we're going to need to add another validation check on the server. Remember, in our in-game script, we had our handle player consumed and handle spore consumed, and these were doing a series of validation checks. So we're going to need to add another one to the handle spore consumed. The way we're going to handle this is we need to see if the player could feasibly have dropped the spore and then moved enough distance to no longer be on top of the spore, and then immediately turn around and eat the spore again. And if enough time has passed for that to be possible, then we're just going to let them do it. Otherwise, we're just going to reject the event. So it's clear that we're going to need to keep track of whether a spore was dropped by a player and what time they were dropped at. So let's add those properties to our spore object. So we'll come to objects, game object, and we'll add dropped by, and this will be a player, and dropped at will be a time.time. And of course, these could be nil if they were not dropped by anyone. So yeah, if we did drop these spores, as in we're in the sync player function and we've dropped a spore, when we're creating this spore, let's just say dropped by is going to be g.player, and dropped at is going to be time.now. Now to do the validation logic. In terms of difficulty, this is probably, I don't know, this is probably on par with checking the distance. So we could probably do it, before or after this check. I'll just do it after this check. So finally, check if the spore wasn't dropped by the player too recently. So we're going to create a new function called g.validate player drop cooldown, and we'll pass in the spore, and we'll pass in some buffer. We always want to have some sort of buffer just in case our server is a little bit off. We'll just do the standard thing here if that validation check failed, but otherwise we'll continue on to here. So let's implement this function. We'll do it after this function here. So it's going to take in a pointer to a spore object as well as a buffer, and it's going to return an error. So basically we need to do a little bit of maths and calculate the minimum acceptable time that could have passed in order for this check to pass. And if the difference in when the spore was dropped and the current time is not within that minimum acceptable time, then we will reject this and throw an error. So because we know the player's speed and we can calculate the minimum acceptable distance, time is just distance over speed. So we should be able to calculate the time. So let's go minimum acceptable distance. And this is going to be the spore's radius plus the player's radius plus our buffer. So the buffer is actually going to be a distance buffer. Then we can do min acceptable time is going to be time.duration, min acceptable distance divided by g.player.speed times time.second. Now we can check if spore.dropped by was our player, and time.since spore.dropped at is less than the minimum acceptable time, then we'll return an error. And we're just including a bunch of information here just in case it's useful to us. But anyway, if we don't return here, then we're just going to return nil. So yeah, so when we're calling this method, we're giving it a distance buffer of 10 pixels, which is generally what we seem to be using here. So I'm going to go ahead and actually change the probability again to just always be 1. And I'm going to run the server. So we're expecting to be dropping spores every sync, and then I should be able to quickly collect them again. Let's see. All right, cool. Yeah, so I'm able to collect the spores after I've dropped them. let's pretend like I was a hacked client, and let me do what I said that someone could do and just disable this check here. So this would mean that they are eating all the spores as soon as they drop them, but the server should not allow for that. So what you're seeing here is me dropping spores and then immediately trying to eat them and telling the server that I'm eating them. But notice how I'm not growing. This is because the server is not allowing this to happen. The server is rejecting all of these events, which you can see in the server logs. No, there's no server logs. Why not? I kind of expected it to be printing a bunch of errors. And I can see that I'm getting bigger as well, which is obviously not supposed to be happening. Let's see if we can figure out what's going on here. Oh, it's probably this buffer is too generous, I would guess. It doesn't really explain why, because my radius should be increasing. Oh, but then I'm just dropping them again straight away. Alright, yeah, this buffer is probably a bit too generous. Let's try having no buffer and see if that fixes it. Let's see. Yeah, alright, so it looks like we need to multiply this by 1000 inside, and this will be in milliseconds. So I think just, you know, duration needs to take an integer, and I was having something that was less than an integer, basically. So it was just sort of defaulting to 0. So it was saying the minimum acceptable time was always 0, which is basically going to have the effect that everything is accepted. But if we multiply by 1000 inside the brackets to get an integer, and then saying that this is a millisecond instead of a second, that should fix things. Yeah, here we go. So yeah, it's just saying, it's just rejecting all of my attempts at dropping spores and then eating them. So every time I try to eat a spore that I just dropped, it's going to reject that, and I'm not going to be able to grow in size. And I might even be able to add my buffer back in. Yep, looks good even with the buffer. We are well within the, well yeah, we're still well outside the minimum acceptable time. So let's unhack our client and make sure that it still works for the legit clients. As in, are we able to allow the onExit method to fire and then come back and try to eat the spores that we dropped? Let's find out. Yep, that seems to have no problem. There's no complaints from the server, even if I try to do it really quickly. Maybe I trigger it a little bit, but in practice, we're not going to be dropping spores as rapidly as this, because the probability is not always going to be 1. So I'm pretty happy with that. So I'm going to uncomment this, and we can say that this feature is now complete. All right, let's see if we can get a search bar on the leaderboard so we can actually try to find our friends. So I'll just give you a little quick, this is kind of what we're aiming for. You should be able to search for your friend's name and it'll highlight and it'll show you sort of like the 10 players surrounding that player that you searched for. So yeah, here we go. If you try to search for someone who is like rank 6, it should show you the 10 players on either side of that 6. So the 6 is centered around from 2 to 5 and then from 7 to 11. So, and if you try to search for someone who doesn't exist, it will just send you back an error that will get logged. So let's try to get that. So we're going to need a new packet. This is sort of always the first thing that we need every time we need a new feature like this. So it shouldn't be too surprising. We'll call this a Hiscore, or I guess we'll call it a search Hiscore message. And it will take a name, and I'll just recompile my protocol buffers. Let's also add a new query. So we'll come into db-config queries, and we'll call this get player by name. So we'll do select star from players, where name, and we could do equals question mark limit 1, but this will mean it's case sensitive. So we, instead of using equals, we're going to use like. So this will allow us to type it in and the case won't matter. Let's also make get player by rank. Oh, sorry, get player rank. So this is what we really want for this feature. When we type in a player's name, it's going to try to look them up, get their player ID, and then return their rank. So we're going to select the number of players +1 as the rank. And you just have to put rank in quotes here because rank is actually a keyword in SQL from players, where best score is greater than. We're going to do a little subquery here. Select best score from players again. And because we're using the same table in the subquery as we are outside here, we just need to alias this. So we're going to call it P2. And then we can say where P2.id equals ? So to use this, first we need to get the player's ID by their name. And then once we have that ID, we can feed it into this function to get their rank. And of course, their rank is just the number of players below them, or I suppose the number of players above them. So that's why we're choosing count star, and the count of players whose best score is greater than the player in question. So let me just recompile my SQL. All right. So in the browsing Hiscores state on the server, we're going to listen for the new packet that we just defined. So let's add a new case to the handle message method. Packet search Hiscore, search Hiscores. So what are we going to do in this method? Well, we're going to grab the player using our getPlayerByName query. Get player by name, pass in the DB context, and we'll get the message.searchHiscore.name. So we're just passing in the name payload from the packet. If error is not nil, we're just going to log something. And we'll send a deny response to the client. No player found with that name. So that's something the client can log, and we'll just return from there. Otherwise, if we were able to get the player, we'll go ahead and get their rank using our other query that we just made. b.queries.getPlayerRank. Pass in the context as always, and pass in the player's ID. We'll check again if there was an error, and we'll just, in the deny response message, we'll just say player is unranked. And finally, we're going to calculate, well, we're going to set the limit of what we're returning is going to be 10, but the offset is going to be determined by the player's rank. So it's just going to be player rank minus limit divided by 2. And then we can just do b.send top scores, and we're going to be able to pass in the limit as well as the offset. And we just need to make sure that the offset doesn't go negative. So we're going to choose the max of 0 and the offset. So what we're going to do is we're going to take what's in the onEnter method, all of this. We're going to cut that, and we're going to replace that with b.send top scores, 10 and 0. So a limit of 10 and an offset of 0. And now we're just going to create our helper method, send top scores with a limit and offset. And we're just going to paste everything that we copied from the onEnter method, except we're just going to let limit and offset be from the parameters. And we can save that. So if we did everything carefully, we shouldn't have any errors, and we should be able to run the game again and browse the Hiscores just as we had been previously. So let's just do a little check to make sure that we haven't broken anything. Looks pretty good to me. All right. So now we actually get to make the Hiscores search bar in Godot. So we're going to redo the browsing Hiscores scene. Let's create a HBox container under our VBox container. And let's move this to the top. Let's move the back button to be a child of the HBox container. And then let's add a line edit node. And we'll set the expand property on the line edit to horizontal expand. So this looks a little bit better. Our back button is in a little bit more of a sensible location now. And let me just set the placeholder text just to say search, so it's clear what we're doing. And we'll add another button to the HBox container, call it search button, and we'll set the text to search. So it doesn't look too bad now, but we would have knocked loose a couple of references by restructuring. So let's go ahead and fix that. So let's open up our browsing hiscores.gd script, and the back button now lives under a HBox container. So we'll add that, just fix that there. Let's put a reference to our line edit and search button as well. And I'll just prefix these with an underscore. Let's connect up these new nodes. So we've connected the back button. Let's also do the line edit .text submitted signal. Connect that to our on search button pressed. We're going to create this handler in a minute, but let's also connect the search button .pressed signal to on search button pressed. And these two handlers are going to do basically the exact same thing. One of them is just when you press enter from the line edit, and then the other is going to be when you press the button physically, but they're going to do the same thing. Let's go and define these here. On search button pressed. So we'll construct a packet because we're going to be sending a search high score message to the server. Search high score message is going to be a packet.new search high score, and the high score search message set name to be the line edit's text. So whatever we had entered in the line edit when we pressed the button or when we pressed enter. And of course we will send that packet. Let's add a log to the scene as well, just in case we need to log a deny message. So just under the high scores, we're going to add a log child node, still in the VBox container, but after everything. Let's just set the custom minimum height to maybe 100 pixels. We don't need that much space. All right, so let's add a reference to our log. I guess we'll add a reference to the log down here under the high scores reference. And let's listen for a deny response message. So elif packet.has deny response, handle deny response, packet.get deny response. And we'll simply log an error with the deny response message's reason. All right, let's try it out. I think I started the server after I changed it. I can't remember. I'll just restart the server anyway. And let's browse high scores. And we're getting the 3 usual suspects. Well, we only have 3. So, I mean, I can type one of their names, but nothing's really going to change. Yeah, I mean, I can put a break statement in the handle high scoreboard. Oh, sorry. Well, yeah. I mean, I can put a break statement here when we've pressed the button, but we know that's probably working. Handle high scoreboard's message. Let's see if that break triggers when we search for Susie. It does. So we can tell that the server is receiving our request and it's sending us back a high scoreboard. It's just that it looks identical to what we currently have because we only have a few. So give me a second. I'm going to register a bunch of clients. All right, and now let's look at the high scores. So I registered more than 10 clients, and let me think of someone who's not on this list. All right, so I know I registered someone called Fred, and he's not on the list. So let me type Fred. Well, does not seem to be working. Let me search, maybe it'll send me a deny. Yeah, okay, so Fred is definitely there. I just need to figure out why he's not showing up. Well, I think what we need to do is clear the high scoreboard before we, yeah, so and let me put a breakpoint here again. Yep, that's fine. Fred. So what's in here? Oh, it looks like it's sending from rank 1. Let me try that again. So limit is 10, offset is -2. Oh, okay. So it's because everybody has a score of 0. So it thinks Fred's offset is 3, when in reality it's well, he's not on the top 10 list. How could we fix this? Could we change the query to say greater than or equal to? Because that would make Fred's rank a lot more than 3. Let's see if that fixes things. Oh, the offset's still -2. Oh, I need to recompile my SQL. Alright, try that again. Okay, that's looking better. So yeah, we were able to search for Fred, who wasn't initially on the list. So because he has a score of 0, along with pretty much all of these other people, if I search for Fred, it turns out he's ranked 14. So it's just going to add all of these new people. We probably don't want it to be like that. We probably just want it to center always on whoever we searched for and then show 10 people on either side. And by the way, I had to change the query to say greater than or equal just to detect that edge case where everybody has a bunch of the same scores. So yeah, if you need to fix this up, just remember to regenerate your SQL, because I forgot while I was troubleshooting this, so it's a little bit confusing. But yeah, if there's going to be more than 10 entries present, and also they might not even be necessarily consecutive when we're just adding them in like this, just to fix everything, we're just going to clear the high scoreboard before we add the new entries. So we haven't actually built a method to clear the high scoreboard yet, so let's do that now. We're going to come to classes, hiscores, hiscores.gd, and we're going to make a new method called clear high scores. And this is going to simply clear our scores array and then loop through each entry. And we're just going to say if entry is not equal to the entry template, entry.free. So that's going to clear our high scores. Now we can come back to the browsing high scores script, and where we handle a high scoreboard message. Before we do anything, we'll just clear what was currently there so we can start fresh. All right, so let's try that again. If I search for Fred, it should sort of center in on him. Yeah, so it's sort of showing, well, let's see, let's search Nile Red. Okay, he's already there. Let's search for Johnson. He seems like he could be in the middle. No, it's still, yeah, it's still kind of screwed up by the fact that there's a bunch of people with the score of 0, but I'm pretty lazy, so I'm gonna leave that as a homework exercise to you guys. See if you can fix this. If everyone had actual different scores, there would be no problem. All right, let's make it so we can actually highlight the selected player. So they should look slightly different to stand out. So if I search for Susie, let's make it not broken. Let's search for John. And when I search for John, he should highlight to make it apparent that he's the one that's been selected. So let's add a new parameter to the set high score method in our hiscores.gd script. And we'll just say it's going to be called highlight. It'll be a Boolean and it'll be set to false. And we'll just pass this in if we actually want to highlight the score that we set, which means we're going to need to pass it in to the add high score method, which means the add high score method is also going to need to accept a Boolean. And just at the bottom here, after everything's said and done, we'll just check if highlight name label.add theme color override, and we'll override the font color property, and we'll just set the font color to yellow. So that should make it stand out. We just need to tell it to highlight if we searched for it. So coming back to the browsing high scores script, right before we set the high score, we're just going to check to see if the name for this row matches what we have in our text box, because that's going to be who we searched for. And we'll use that to set a highlight variable. So highlight is name.toLower matches line edit.text.toLower. And then we can pass that into the set high score function. So now let me search for John and he should highlight. Cool. Looking pretty good. Well, that's actually the end of this video. So just to recap, we added a new mechanic to keep players engaged. So players drop spores now. They can lose mass over time if they're not careful. And now there's a search feature to encourage friendly competition. So you can search for your friends, and a bit of social interaction is essential for any MMO. Even though we have technically a fully functioning game at this point, there's still much to be desired in the looks department, as you can see. So the next video is going to be dedicated entirely to just polishing up anything that needs a bit of a facelift and making the game look as good as possible. This will set us up nicely for the final part, which is not next video, but the video after that, where we will look at how to actually deploy our game and make it available for others to play over the internet. If you had any questions or feedback, don't be shy to join the Discord server, where there's other game developers who are following along the course, happy to discuss anything that might pop into your brain. You can also leave a comment on the YouTube video to discuss down below, and press the thumbs up button if you liked this video, because it'll help other game developers find this course and we can grow our community. But until then, I'll see you in the next video.